live session. We have a fantastic topic today with a fantastic speaker in the form of Dr. Lodovico Parmegiani. He's from Italy. He is the lab director for Next Clinics, which is a chain of upcoming IVF centers in Europe. And I'm sure you're going to hear his name quite a lot in the near future. He also hails from Bologna, and he looks after the Gynae Pro Medical Center in Bologna. He's the lab director of that unit. And the best part about Lodo is that he is an amazing thinker. He's actually optimized so many techniques and so many devices. And that's what we're going to talk about today, because one of his products is sterilization of liquid nitrogen, which he's working on in Italy. And during these times, especially during COVID, this could be a potential time bomb for all of us. And we're really looking forward to actually having a wonderful discussion with Lodo today. So he's going to actually talk for about 15 to 20 minutes about COVID and the situation with liquid nitrogen in these times. And then we're going to take the questions in. So please put in your questions in the chat bar, and I'm going to be moderating them to Lodo, and we're going to actually, hopefully we're going to have quite a lot of take-home messages from this session today. So Lodo, the floor is all yours. You can begin in right now.
Okay, Keshav, thank you very much. Thank you to Meta for this kind invitation. It's a pleasure for me to be in here. And now it is 3 o'clock in Italy. So thank you for your kind introduction, Keshav. As Keshav said, I'm an embryologist, and I'm a lab director here in Bologna, Italy, which is a town in the center of the northern part of Italy. And I'm also the head of embryology for this new group. I have basically scientific role in coordinating the other lab managers inside this new group. The name is Next Clinics. And then, of course, I have to disclose my conflict of interest, because I'm a founder of a startup which is involved in liquid nitrogen sterilization, and we do this for IVF, for healthcare in general, and now we started also for food manufacturing, deep freezing, and also food and beverage. Many applications. So let's start with this pandemic, we start to understand which is the risk related with liquid nitrogen. So let's consider if COVID-19 is a potential time bomb in liquid nitrogen. You know that we were informed about a second wave of contagions in China, in Beijing. And with the suspect is that probably the food or the frozen food have brought the virus from Europe back to China. So maybe this is just an hypothesis, but this is to let you understand that this can be a problem in the future. Maybe we think that we have finished this pandemic, but maybe the liquid nitrogen is still contaminated. And this can happen now with COVID-19, but in the future it's also with other contaminants. So let's go ahead. Okay, so liquid nitrogen is a key cryogenic agent, including and freezing for food and beverage, and also used in healthcare, of course. Liquid nitrogen can be contaminated because contaminants were found inside cryobanks, also in IVF cryobanks, and it is possible to find viruses, bacteria, fungi. Contamination creates potential risk for biological specimens, patients, and food quality when we use liquid nitrogen for food manufacturing. So many applications potentially require sterile liquid nitrogen. Of course, in a human-assisted reproduction, during vitrification, warming, cryostorage, and handling of cryostored samples. We have to have in our mind that the waste of money due to contamination in assisted reproduction has been estimated in around 100 millions per year. 7 millions in US, 7 million in UK, something like 4 millions in Brazil. If we consider, and this is just for the contamination that we can see. So contamination that stops IVF treatments, okay? And also, if we consider the adverse effect of contamination in food and environment, we have 1 million of deaths per year of food and environment contamination. So, contamination of samples may occur during the storage of cells in liquid nitrogen or nitrogen vapors, which are the potential sources of contamination. Other crops have samples stored in the same vessel, so we call this cross-contamination. So I guess in this period we are worried about the fact that if we have potentially a patient that are infected with COVID, if we store these samples and potentially these had virus in the gametes, that we need to demonstrate this. This can infect in the tank other specimens. I would like to say to you, and I say to you that this is a very far from happened situation. It's not. I don't think that we should be worried about this, but this is what embryologists are mainly worried now. The real problem, in my opinion, is the liquid nitrogen themselves, the liquid nitrogen and nitrogen vapor themselves. Liquid nitrogen itself can be contaminated. This because we have no guarantee about the traceability of purity of this liquid nitrogen from manufacturer till the use. So the cryotanks in a laboratory are exposed to potential risk of contamination due to refilling and handling of specimens. We know that ice crystal will form on the walls of the vessel, and then aggregated ice and sediment entrap viruses, bacteria, and also fungi. Airborne contaminants come in contact with liquid nitrogen vapors and remain cryopreserved. Although some industrial sectors, drug manufacturing, food and beverage, sterile packaging, carry out a raw filtration. This is because they already were worried about potential contamination from liquid nitrogen. So this raw filtration, it cannot be a guarantee of sterility, because this cannot be effective against smaller microorganisms like small bacteria and viruses. So in this case, this filtration can be effective against COVID, just to give you an example. So during this pandemic, manufacturers of drugs, disposables, capsule media are trying to mitigate risk by sourcing raw materials to low-risk regions, but this is not applicable to liquid nitrogen and nitrogen vapors, which are manufactured near our laboratories. So this can become potential vectors of contamination. I was worried during the last months, because we were receiving liquid nitrogen from the north of Italy, and the manufacturing sites were inside the red zone, in which we had the highest contagious, the highest spreaders of the pandemic. So aerosol and surface stability of COVID-19 has been investigated, and we know that this can persist in surfaces for many hours. This depends on the type of surface. But the risk of this virus being accidentally cryopreserved in liquid nitrogen and nitrogen vapors has not been yet studied. So we have to consider that COVID-19, liquid nitrogen, nitrogen vapors, or also in other refrigerated ambience, it is a potential time bomb. Coronaviruses, as well as other viruses, are cryopreserved the liquid nitrogen, nitrogen vapors. They immediately vitrified in contact of low temperature. So the use of a contaminated liquid nitrogen, nitrogen vapors risks virus awakening and the contamination of thawing cell, environment, and operators. So we are continuously using liquid nitrogen in our lab. So the potential risk is to reinfect our surfaces, worktops, operators, and then cells at the very end. So we read assisted reproductive technologies practices that were provided by the main scientific societies. So the suggestion was during the pandemic here in Europe to cancel all fresh embryo transfer and then freezing for later embryo transfer. So just imagine that potentially now, because we're starting now in Italy to do IVF, we can take out the virus from our cryo tanks, and then we can reinfect the environment. So we know that now vitrification is the gold standard to cryopreserve oocytes and embryos, particularly open carriers are preferred to vitrify oocytes, and so we cannot exclude that the risk of cells contamination during this open vitrification can occur if liquid nitrogen is potentially contaminated. But the real risk that we have is also a risk related generally with liquid nitrogen. So if in the past we were safe with the closed system, now we have to consider that potentially, so the risk is to reinfect the environment through liquid nitrogen. So there is no more difference between open and closed carrier. The real risk is the liquid nitrogen itself. This was the model of potential contamination in liquid mediated by liquid nitrogen. You know, we have microorganisms that are frozen in liquid nitrogen. So just let's imagine that this is the COVID, and then this can go in touch with the carrier. Then when we plunge the carrier in culture medium at 37 degrees, we may reactivate the contaminant, in this case the virus. And then, of course, this is real that in culture medium we have antibiotic, but this cannot work against virus, for example. Even in closed system, an accidental contact with liquid nitrogen and nitrogen vapor may occur during storage and warming of material. The fact that infection traceable to cryostorage has not been reported after millions of embryo transfer until now may be due to the reduced dosage of infective agents during laboratory procedures, but we have no control about the potential titer of COVID in our cryotanks or in our supply chain for liquid nitrogen. So the risk of infection is real, especially when new highly infective agents arise. So just to give you an example, we were relaxed now in Italy. Today, here in Bologna, we were informed that a courier company had, some spreaders inside the company. So the risk is that the infection is coming back. So I guess that you have heard about the use of UV radiation to kill virus. So now we have also information that also the solar energy, so UVA and UVB can kill quickly the virus. Anyway, UVC radiation is very effective to kill any kind of virus. And this is a device that we developed with my startup that allows the embryologists to decontaminate very quickly the liquid nitrogen, and the energy that we are supplying is 10 times higher the energy necessary to kill a virus. Okay, just to give you an example, for hepatitis is 8,000 UV dose, which is microwatts second per centimeter square necessary, and for coronaviruses is 10,000, and we give something like 600,000, okay, in 10 minutes. So we have to consider that I gave you the example of the courier that were delivering common parcels and boxes. But when we work with gametes and oocytes, we do a lot of manipulation. This is, for example, what we do between Spain and Italy with shipping oocyte for gamete donation. Okay, so if we consider that we do many manipulation, the oocytes were vitrified in a styrofoam box in polystyrene, and then they were put in a cryo tank for a temporary cryo storage. Then they were prepared for dry ship, and then they're shipped with a courier. So all this manipulation were done with liquid nitrogen, and liquid nitrogen can potentially infect the specimens. That's the reason why any manipulation should be performed with sterile certified liquid nitrogen. In this way, any manipulation is a dilution of the risk of contamination. If we wash a specimen, we can decrease the infection. So the idea is to do washing of gametes. Of course, we can do it after thawing. So during, these COVID procedures, we increase the washing of gametes after thawing, after warming. But the first step should be a washing with sterile liquid nitrogen. If we perform this washing that was described for the first time in 2012, we can dramatically reduce the potential risk of contamination. For example, when we perform this study, so you can see the contamination, we use the contamination that was 10,000 times higher the contamination even found in an IVF cryobank, okay? And then we contaminated the liquid nitrogen, and what we did, we put the carriers, any kind of carriers in liquid nitrogen. When we when we took out these carriers, we analyzed that 100% of these carriers were contaminated. So what we did, we washed this carrier in sterile liquid nitrogen, and a simple washing, so just swirling this carrier for 30 seconds in a clean liquid nitrogen allowed us to have zero contamination. So the idea to decontaminate this carrier by washing this carrier with liquid nitrogen is and then having the certification of the sterile liquid nitrogen used for this washing is a reliable trace for quality assurance that we can use in our standard operational procedures in the lab, and this is also compliant with any strict regulation regarding the minimizing contamination during handling. You know that in Europe we have this strict regulation that suggests to minimize any risk of contamination when handling cell and tissue. For this reason, in some countries, it was forbidden to use open carriers, for example. And now the problem is not only related with the carriers, as I told you, is related to the safety of liquid nitrogen. And then, of course, what we should do also is to clean inside the cryotanks. This is another product that we developed in our startup to clean the inner walls of the tank, the cryotanks. Of course, we have to keep in mind that once we did this sterilization, potentially, so this is to perform the annual maintenance of the tank, saying that we are cleaning periodically the cryotank. But the suggestion if we would like to put in practice a very straightforward procedure to minimize any risk of contamination is to wash your carrier with sterile liquid nitrogen. So in conclusion, my plea is not to underestimate the potential risk of liquid nitrogen vapors mediated COVID-19 infection. We need to put in place strategies to prevent this eventuality in our laboratories, but in the future, also in food manufacturing. There is an urgent need to have safe food. So if you look to the hashtag food safety, this is what it is more growing. The hashtag most used in the food sector in the social media. So we need to put in place procedures aimed at minimizing contamination during vitrification, warming, handling, and also during cryo storage. So I finished my presentation and I'm ready for your question. Hope this wasn't boring for you. Let's stop to share the screen, and then can you see me?
Yes. Thank you, Lodo, for that fantastic presentation. Not at all boring. I'm very sure that it's very useful to all of us, and we already have a lot of questions. Before we begin the questions, I'll just summarize a few points which you mentioned, and please correct me if I'm wrong. What you've mentioned is that there is now no difference between open systems and closed systems as far as the risk of contamination is concerned.
Okay, I can comment this. For many years I was contacted, invited to talk about the potential risk related with open carriers versus closed carriers. Yeah, so if we consider the cross-contamination, of course, closed systems are safer, okay? We have to consider that nowadays 99% of the carriers are open carriers. And then what
That's
we
true.
are, so we are not stupid, but the majority of brands are marketing these carriers as closed carriers. We are an independent, scientific society. We can, if we look at the information for use of any of these carriers from the big brands such as Cooper Surgical, so I would say Vitrifit, Cryolock, you can say that is marketed as closed, but the majority of people is using this carrier as an open carrier. So yeah, we cannot hide ourselves. And then also closed cryotop is not so used. So the majority of us use our open carrier. Given this, so we can say the safest model is the straw in straw. So with the straw in straw, we put the embryo in the inner straw, and then we put in other sleeve, we seal it, and we plunge it in liquid nitrogen. This can be efficient in some ends and not so skilled, so we prefer to use the open carrier. But if we consider that the potential risk is the liquid nitrogen, also with this closed carrier, the risk is that you bring near your microscope your box with liquid nitrogen. And if you have contamination in your box,
Yeah.
of course, the virus, like COVID, which is an airborne contaminant, can be spreaded in the laboratories. So this is the risk. Nobody is talking about this risk. Again,
Yeah.
if you read the papers, they are suggesting the safe rule to avoid contamination from patients. This is not risk. This is not risk. I don't think this is the main risk. The main risk is liquid nitrogen. So
Yeah.
I would like to change the focus. But of course, I have some papers in publication. Maybe this will change this perspective.
That's great. And when I was going through like your papers, uh, you talked about the other viruses which exist like hepatitis B, HIV, etc. Now, at the point of generation of liquid nitrogen, obviously because these are not respiratory viruses, the chances of contamination of liquid nitrogen from the source is going to be less. But with COVID, you very correctly mentioned that this virus being aerosol generated or maybe even airborne for a few hours, it can affect right from the source of contamination, from the source of generation, and it can be a very potential risk to all of us. And it's not just the IVF industry, it's the food industry as well. And thank you so much for actually bringing that very important point out. So let's go to a few questions. We have a question from Om here, and he's actually asking, how do you actually sterilize a new cryocan? And is that even required?
Uh, yes. So I showed that we developed a plug, which is a universal plug that can be fitted to different tank. Um, so this plug is something that I did it for my lab. Okay, I did it for my lab at the beginning because when I realized that when I asked to my gas supplier to clean the tank, I asked, "Can you do for me a certification that this is clean?" And he said, "No, I can't. No, I can't. I can say that." So I said, "Okay, I will do by myself." When you are giving this UV energy, which is the double the energy that we need to kill any microorganism, as I published in 2009. So at the very least, we have the certification that that UV rays has been given. So the idea is this. So what I do? So we have to consider that potentially all the cryotanks can be continuously contaminated. So what we can do, of course, do general maintenance. As for our fridge in our house, I think that periodically, just one per year, we are cleaning the fridge, okay? So if we can clean this fridge, maybe only taking out the samples, but by keeping the liquid nitrogen, this can be, smarter and easier because at the very end, it's impossible that we keep our cryotank without any cleaning procedure for years and years. Okay, so I think so. The idea is this. So how many times per year we need to decontaminate the tank? I don't know. I don't know. This is something that we should do in a
On a
defining
regular.
our lab.
Okay.
And in the future, what we are doing now with my startup, we are working to do a sterilization system that we can use for big plants. So we can guarantee that the liquid nitrogen that arrived from outside is sterile before use, and will help again to keep clean the cryotank.
And you mentioned like you can wash the cryo tanks with sterile liquid nitrogen, and that ensures sterility, or that actually reduces the kind of contamination. So that could be a potential good
Yeah,
way of.
the idea is to wash the single carrier.
Okay.
So at any warming, I can share with you also some videos, because now what we did the conventional box for vitrification. Then
Yeah.
imagine that you have a a sterile box, already sterilized. You put the sterile box, so you don't need to clean anything. You fill it with liquid nitrogen, and then you sterilize with liquid nitrogen. So in 10 minutes, you have this clean, certified sterile liquid nitrogen. You plunge the carriers inside the tank. Oh, you should have one of these. Sorry, I got it here. So, oh.
Okay.
This is a medical device. This is a medical device. You fill it with liquid nitrogen. You put in UV. You take out with a cover, and you plunge your carrier. You wash it for 30 seconds, and that's it. So this is a very easy to implement way, and then this has the cost of a carrier. Okay, at the cost of a carrier, you will have the sterility. You will minimize the risk of contamination. That's it. It's very simple. And then, since I'm an embryologist, what we are doing, we are giving for free as a loan the device, and you buy just the sleeve. It's just coffee machine. You buy the pots for the coffee. That's it.
That's awesome.
Of course, this is a model. I'm on startup. We start to sell this in Italy and in Europe. Let's see what happens. Yeah.
You should come to India now.
Why not?
Okay, so have you actually changed your protocols in your clinic, and are you like freezing the embryos and oocytes separately at the moment, or like it's the same cryotanks that you're using?
This is a good question. Again, since I don't think that the risk is related with the patient, and the risk is liquid nitrogen. So this means that also if I keep separated, potentially also the other bank can be infected, because the risk is on the liquid nitrogen we are using. So we are not keeping separated. We are just performing the washing at warming.
So I think that will answer a lot of questions here, because a lot of people are asking whether you store the sperm separately, embryos separately. So Saroj has asked the same question. Om also has the same question. So if you're sterilizing your liquid nitrogen, then probably we are safer. But if you're not, then you probably need to take some precautions, like maybe opt for a closed system or something like that. But again, you have to be worried about the contamination which is coming directly through liquid nitrogen. There are a lot of questions on how do we ensure that the liquid nitrogen is sterile, and we know that UV is an option, and you've told us about it. But when we are cleaning our tanks, we're taking out the canisters and putting it into sterile nitrogen. That canister could be contaminated as well. So how do we really, and especially for older tanks?
Yeah, this is a good point. That's the reason why we are suggesting that method, that sterilize the cryo tank with the UV light and also the canisters. Okay, of course you can not leave the specimen inside, because this can be dangerous for the DNA. Okay.
Yeah.
But this is perfectly because also the distributors say, okay, we buy the plug and we give the plug to the customers. They clean the liquid nitrogen. They use this. I say no. This can be something that we do additionally, but to be sure, we need to wash the single carrier at warming. Before warming, we wash it, and then we can certify that better if this carrier is closed. At the very least, it's closed for storage. So what I do, I prefer to use open vitrification, and then I close it with sealed system. In this way, then I put in a sterile liquid nitrogen, I do this washing, and that's it. So this is an easy to implement method. Of course, we can clean our tank, but after 5 minutes we can have a recontamination. So it is impossible to control. It is impossible to control this.
And this was wonderfully mentioned in your paper as well, where you've shown images of actually taking out the straw and measuring the temperature during the transition as well, and it never went below 180, if I'm correct. So
Yeah.
there's absolutely no risk of losing
Yeah.
out on
To
your
to
embryos
be
also.
honest, now we the paper. Oh, thank you for reading the paper. It was from 2012. Now we changed a
Yeah.
little bit the procedure, and we use a single box, okay?
Yeah.
Because we said that it's effective as well. I can share with you also videos to show, because it's
That
very simple. Of course,
that'd be great.
probably this happens also with fresh liquid nitrogen. But if you use fresh liquid nitrogen, we don't have the information about the contamination of that fresh liquid nitrogen. So what we have to do to sterilize before, having the certification that this liquid nitrogen is sterile, and then dilute the potential risk, because we are all agreed that the risk is minimum. Okay, so the risk is minimum. As many authors have demonstrated, it is very rare to have a cross-contamination. Not cross-contamination we have registered in IVF. So this is just to put an additional step. So I agree that I don't want to make terror and say you need to be worried, but this was the missing chain. So
Yeah.
everything we use in the lab is sterile and certified. So we need to use sterile and certified liquid nitrogen before using. And also the
Okay.
quality of liquid nitrogen is important, because our supplier can give different grade of purity of liquid nitrogen. You know that there is a medical grade for
And
liquid
then there is
nitrogen, there is a
food grade.
food, and also for industry, they use liquid nitrogen, to modify metals. So this is extremely unpure, not very pure. Okay,
So
so we need to prepare that.
I think in India, like I'm also not sure, but from my knowledge, we only get food grade liquid nitrogen in India. I'm not sure about it. So if anyone has any comments on it, I'll take them. But do you think that this is again a potential concern for people in India?
I would say that food grade it is already good, but
It's good.
I'm not sure that it's food grade. It is
Okay.
food grade because the half of liquid nitrogen, the gas manufacturer manufacturing is for the deep industry. They use it for chip production, microchip production, but they also use it for modify metals. So in that case, they don't care about the purity of liquid nitrogen. They just look at the temperature, okay, and not at the sterility or the purity, okay. That's the
Yeah.
reason why, of course, they would like to avoid to have oxygen inside, because this can create problems when they use that for that processes. But the food is an advanced grade of purity, and then we have the medical device, which is more pure.
Okay.
Anyway, this is only regarding the other gas concentration, the other molecules inside the liquid nitrogen. Unfortunately, they cannot guarantee about microorganism presence.
Okay, so when we're talking about microorganisms here, uh, we know that viruses can survive, but there are papers which say that even bacteria and maybe some kind of spores can also survive in liquid nitrogen. Do you have any comments on that?
Yes, there are papers from Bielansky, Morris, Ted, and early 2000, and they found these contaminants in cryotanks. So there are some fungi and bacteria that can affect also embryo growth. When we did our experiment of false contamination, we used, as I said before, 10,000 times the concentration of microorganisms even found by these authors. And then by doing the washing, we were able to say that the contamination was zero. That's the reason why the simple washing can minimize any risk of contamination. But we have to consider that our cryotanks have bacteria, have fungi, molds, and may hopefully not virus, but the only cross contamination, not in IVF, that was found was done by HBV. HBV in bone marrow transplantation was reported on Lancet.
Okay, it's still not happened in IVF, but it's happened in bone marrow transplantation.
Yeah.
Okay, good to know that. I didn't know that. We have a question here from Sonal, and I think it's an easier question. The unit that you're mentioning can be set up in any space, right? Because it just gets attached to the cryocan, which I could like decipher from the pictures that you showed.
Yes, you think the plug? Yes.
Okay.
But this is the we call it plug and plug. This is this was designed to sterilize from the dry shipper to 50 liters containers, and then with the startup we are scaling up the model to have big dewars. But this is what we will do for food industry. On the contrary, the box it is very quick, because we have to consider also that the plug is not so quick. It takes a couple of days to sterilize a tank. With the box, where you put this
is 10 minutes.
Less than 10 minutes. 10 minutes. Yeah.
Okay,
so just the time that you put the oocyte embryos in equilibration, write the name, and then you have sterile liquid nitrogen. So it's very simple to use.
So even if the nitrogen in your cryocans is not sterile, but when you're cleaning the nitrogen during warming, this should be perfectly fine.
Yeah.
Awesome. Good to know that. We have another question. Nentara is asking here, can we use any other like devices which have UV or the normal laminar UV lights to sterilize nitrogen?
Yeah, I started in this way. So usually when I do my presentation, I show the first device that I did in-house with a UV lamp. About what is the difficult to demonstrate that we are giving the right energy, and also the efficiency of the lamp is lower at low temperature. This is the principle of one of the patents that we have. So to check the energy that the lamp is giving. So of course you can do it, but you need to validate it. So the technology is very simple, but now everybody would like to sterilize liquid nitrogen with UV is under our patent, the patent of my startup.
That's
so maybe
awesome.
I found investors in India, I don't know.
That's awesome. Okay, so if there are any investors in India who are listening to us right now, please contact Lodo and give me a royalty as well, because I introduced him to you.
Of course, I will give you the fee. Yeah. Sure.
Okay, so Dr. Suhasini is here, and she's saying that is there any method to find out whether the liquid nitrogen that we have in our laboratories is contaminated? I did read a few papers where they were taking like culture plates and they were just putting the straws on the culture plate and checking for growth. I'm not sure if that's the way to do it.
No. We do it. We do it. For example, in our laboratories, we periodically also check with the plates the growth. What we do also, we check if the lamps periodically are working well, and we use spores that are activated at high temperature. So we irradiate the spores, and then we have a sample not irradiated, and we check this. Of course, in the laboratories, any worktop is checked with agar plates. So the Ministry of Health in Italy would like that we do this every day, which is impossible. So we do it monthly, and then every 6 months we have an independent auditor that come, independent inspector that come to do it. So it is expensive, but so it is impossible to do it every day. sometimes the inspectors say, oh, you need to do it every day. It is impossible in the worktops and also in the cryotank. But of course, it's very difficult to test the liquid nitrogen, because you can take a sample of liquid nitrogen and maybe the contamination is on the in the bottom of the tank or near the neck. So the way of sampling can affect the results.
And there are a lot of times when there'll be like debris, or there'll be like ice which will settle down at the bottom of the tank, and that might be holding the contamination. So you're never really sure what part of the tank that you're testing. So again, thank you for answering that. Is there any particular wavelength of UV that we are looking at? I'm not sure if that is patented, but like, is there
yeah, to 253 nanometers.
Okay. And 10 minutes is what is actually being recommended for the smaller box.
10 minutes is for the geometry that we used. Because this depends on the distance of the lamp, power of the lamp, the geometry of the container. We use reflective mirrors, okay? As well as we use reflective mirrors coming from aerospace industry for the plug, okay? So we calculated the reflection, and with this, we have the time. You cannot say I buy a lamp and they put 10 minutes over the liquid nitrogen. You cannot have any information. That what we have also a label, because we have a double label system, and we have a label in which change colors when we reach the right UV irradiation. So this is a second proof. You take out this label and you put it in the label that the sterilizer bath is giving from the printer. So you have the information about the duration energy given, and also that this energy effectively reach the liquid nitrogen, because we have this change of colors of the label.
Okay. How safe is it to use for the people who are working in the laboratory? Is there any exposure that's happening to them? Or
this is another good question. So thank you for saying this, because I said I did it, but I put at risk my eyes when I did it. So it is very dangerous, because UV rays are dangerous for the eyes. So of course, now that the bath that we use for this is a medical device. It takes something like 7 years of trials to prove the safety. So UV rays are not going outside because this is the
okay. So the device is actually covered, and there's no UV that's going to escape. That's how the embryologist's safety is going to be maintained. So thank you, Saroj, for that question. A very, very important question that you've put through. So most of the people in the chat section are saying that in India you get food grade liquid nitrogen. So technically that's not going to be as bad, but we still need to worry about, especially during the pandemic situation. Let's talk about the single use. So there is a question: are these sterile liquid nitrogen containers single use? The ones that you're mentioning.
This is we give this, we give one of these. So we changed the way to work. What is particular that this is already a medical device, certified medical device. So this is the first box medical device. This is as well medical device, and this is single use, very resistant at liquid nitrogen. So this is a medical grade EVA, and so it changed a little bit when it's cold, but it's perfect to be used. And also it is limiting a lot evaporation. So this means that you are not losing liquid nitrogen, okay? Because it is very insulating. And then of course you can reuse the liquid nitrogen. You put the liquid nitrogen in another box and you re-sterilize again. But this is single use.
Okay. We have another question here, and I think we've already answered that. So let me try and answer that. So Abdullah is asking that you need to remove all canisters and clean the tanks. Now, what has been mentioned so far is that you just need to sterilize the liquid nitrogen that you're using for thawing or during the warming process, and that should take care of the contamination with that sleeve, because you just wash the sleeve in that sterile liquid nitrogen, and it should take care of contamination. But you should be thinking about at least cleaning the tanks maybe once a year. So that is that something that's recommended?
Yeah, yeah.
Yeah.
And maybe in the future also feed all the tanks with sterile liquid nitrogen. This is
Yeah.
another additional. So you say before the clinics can occur anything, but when these enter in the clinics, we sterilize it and we feed with the sterile liquid nitrogen. And then of course in the lab we can contaminate the liquid nitrogen, but we are keeping the environment contamination controlled. The liquid nitrogen is sterile and certified, and then periodically we are cleaning the tank, and then at the very end we continue to use this in this way. So I think there's no risk. So until now we are doing anything of this. So if we add this step, nobody can stop us to do vitrification, because the problem is that when you have regulation that try to stop you in doing to do something that that it's very efficient. So all these ideas were born 10 years ago when we started to do vitrification, and when the legislator started to say, at least in Europe, that we cannot use liquid nitrogen to to cool down directly the cell, because it wasn't controlled, it wasn't sterile. That's the reason why I continue to investigate in this field.
And you have very stringent guidelines from what I know, like the European Tissue Directive is what you're talking about. And they basically look after all of these issues. And I think even the FDA has issued some kind of a notice regarding the safety with liquid nitrogen, if I'm not wrong. But in India, we don't have these guidelines yet, and that's one of the reasons why it's solely our responsibility at the moment to ensure that patient safety is our prime goal in the clinic. We have another question from Siley.
Okay. This is also
Yeah.
Sorry.
Okay, so we have another question, and this is regarding HPSAG. So they are storing their HPSAG positive patients in separate tanks. Is there any evidence that during thaw that the embryo might contaminate the liquid nitrogen, and then we discard the box, or discard the nitrogen? If do you have any comments on that?
So to be honest, I still continue to think that the potential contamination of a single cell it is very low. It is very difficult that it's the specimen that can contaminate the tank. But this is my personal opinion. I would be more worried about that we have no information about the liquid nitrogen that we are using. Okay. But this is just my personal opinion. So we are very focused on the guidelines about the risk brought by these gametes. Okay, but I think it's hard to demonstrate that we have an high infectious title of virus in sperm and in the oocytes. Okay, this can contaminate the liquid nitrogen. So we are not focus on the real matter. The matter is the liquid nitrogen, and unfortunately, nobody is talking of writing about this in nowadays. Okay.
Yeah. So again, just to clarify here, and there's another question which followed that question, and this basically says that if the infection is coming from the patient, and if we know that that patient is infected, and we are using an open system, that contaminates, hypothetically, it contaminates all of the liquid nitrogen that we used for that patient during vitrification.
Yeah, potentially, but this is just my personal opinion.
Okay.
I won't be worried about this.
Okay.
We will be much more worried about that we have no information about the liquid nitrogen that we are using. We have a study from Anna Cobo performed on IVF patient. Of course, this was IVF, and they tried to demonstrate that there was no cross-contamination in an infectious patient in the tank. So that contaminant title should be low, but we don't have information. For sure, in liquid nitrogen, the virus cannot replicate. It is frozen. Okay, so so now that the experts are focused on this risk, the risk that the virus is in the gametes. I'm not sure that this is the real risk. The risk is that the virus that we receive in our tank, or that some operators can contaminate the liquid nitrogen.
Okay. So
Can
another
you hear me?
question. I can hear
Because
you now. Your video got stuck for a minute.
I cannot.
Can you hear me, Lodo?
I missed you.
Can you hear me right now? Sumit, I think we're having trouble with the audio. Can you hear
I'm
me,
sorry, I
Lodo?
cannot hear you.
Okay. Can you rejoin? Sumit, can we help him? So I'll just.
You need to log out and rejoin in case you want to.
So can someone contact him? In the meantime, I'll answer a few questions.
Okay.
Okay. So Sonal has a question here, which basically says that do we need to have a separate tank when we sterilize liquid nitrogen?
Keshav, can you hear me?
Yes, I can hear you
because
now.
I cannot hear you. I cannot hear you.
Can you hear me now?
I'm
No.
sorry.
So let me just type it in chat. Okay, so Sonal has a question here, and I'll just answer that till we sort out those technical issues. You will obviously, if you're thinking of cleaning the tanks once a year, you would need to have a separate tank where you can store the samples. But what Lodo's mentioning here is that while we warm the samples, or when we can just take those small containers and use sterile nitrogen there, and that should look after your contamination issues. For that once a year option, you need to have a separate tank so that you don't lose out on like precious embryos that are there already in storage. And you can't really clean a tank which already has samples in it, so they need to be shifted to a separate tank. Saroj also has a question here which basically talks about the same, where we need to actually have a separate tank, and in the meantime you can clean the tank. What he was mentioning was that you use just sterile nitrogen to clean it. We should look after the issues, but otherwise what I've read in literature is that you can actually use bleach and you can actually use detergent to clean the tanks, but I don't think anyone else has tried that. Right. So if anyone else has any questions here, we'll take up those. In the meantime, Lodo joins. We still have about 10 minutes to go. I had just one more question about vapor freezing, which I wanted to ask him, because that also is a potential risk. Now, we all know that vapor freezing might be safer. It might be safer as far as cross-contamination is concerned, but if the liquid nitrogen itself is contaminated, the vapors which are there or the air that is there will also get contaminated. And in those situations, your sleeves will have those microorganisms on them. And that's one of the reasons why we need to change our thinking. And that's one of the reasons why we actually had this session today with Lodo, that you have to now think that the source of infection is not, could be the patient, but it could be your liquid nitrogen itself. And that's really, really scary as far as COVID is concerned. Okay, so can you hear me now? You need to unmute yourself.
Yeah, sorry, I'm back. Because I don't know, it was impossible for me to hear you. Anyway,
Yeah,
I'm
no
sure
worries.
you summarized perfectly my.
I did. I was just going to ask you about vapor freezing,
Yeah.
and that was probably going to be the last or the second last question that we have. Does it carry the same kind of risk, or is it still risky when you're using vapor freezing? Because
So yeah, but potentially we know that we have a in the market a device that it is marked as closed and safe because they use vapor. Should be
yeah,
this.
yeah,
Anyway, there is an article that I did in 2012 on fertility and sterility, in which we commented that the vapor, so the supercooled air is a vapor phase. And there are some papers in which there is demonstrated that if we have bacteria in the liquid phase, we may have potentially bacteria also in the vapor phase.
yeah,
And so potentially we have the same risk. We have the same risk. Potentially
okay,
it's the same risk. So hypothetically, so
yeah,
again, I would like to say we are not spreading the infection. Okay, we will just say safe. You said before that nobody is protecting us. So if we have something that can demonstrate that we are working in a safe manner, certify this. If tomorrow we have any problem, we can say, okay, I did this, I got this certification, I did this, I did the maximum it was
yeah.
possible in my hands to do this.
Yeah, and that's what is important, because if I don't know about the kind of litigations that happen in Europe, but in India, if you're taking the maximum precautions, if you show to the authorities that these are all the things that you did, probably you'll have an easier time with all of those
Yeah,
litigations. And yeah,
yeah, yeah, yeah,
okay.
yeah.
So last question. This is coming from Satya. What is the time that is required to use after UV sterilization? So as soon as you're done with the sterilization process, you can immediately use it, or do you leave it for some
Okay.
time?
No,
Immediately
no,
use
no.
it.
Immediately use, yes, yes.
Yeah,
I have some,
perfect.
if you go to the website, the name of the technology is Sterilizer. It's like
Yeah,
sterilizer, but with N of nitrogen. You will see
yeah.
the videos. Very, very, very easy to use it.
Awesome. Thank you, Lodo, for joining us today. Thank you for a fantastic session, and thank you to all the
It was a
participants
pleasure, a pleasure.
for all the amazing questions that you asked today. And Ludo does have videos which are there on the website, which I would recommend all of you to actually
Yeah,
go ahead and
please send
see.
me the link. I will push in my. I'm not very social, but with LinkedIn, I have a lot of contacts. So I
Okay,
do my best with LinkedIn. Yeah.
awesome. So I'll also get in touch with you. I also got in touch with you with LinkedIn, and
Yeah, yeah, yeah.
I'm going to
Okay.
I'm going to pester you a little bit more
Yeah, yeah, yeah.
uh, on LinkedIn. That's pretty much it. Thank you so much, everyone, for joining today. Thank you
Thank
to
you.
the IT team, and special thanks to Lodo for joining us all the way from Bologna.
Thank you. It was a pleasure. A pleasure. Thank you
And
very much.
hopefully we'll have some more sessions in together.
Yeah, yeah. Ciao.
Awesome. Bye
Thank
bye.
you. Thank
Bye
you.
bye, guys.
Ciao,
Ciao.
ciao, ciao, ciao.